This question, subarray sum equals K, is a medium-level difficulty question. The question provides you an integer array nums and an integer k, asks that you return the total number of continuous subarray whose sum equals to k. As you can see here, a brute force solution involves two for loop and a sum operation. Therefore, it has a time complexity O n cube, which is very computationally costly. How can we improve on the time complexity? When you encounter a subarray sums question, consider using the prefix sums technique. You may pause the video to read this slide in more details. In general, prefix sums are particularly useful to calculate a subarray sum. As you can see here, in a zeros index array, the sum of an array slice set from elements 6 through 9 is simply PA minus P4. Generally, subarray sum of A, ij, this pair index, can be calculated using the difference between two prefix sums. Therefore, you just need to calculate all the p's one time with On time complexity, and then you can calculate any subarray sums as needed in the future. Back to the original question, it asks for the total number of continuous subarray whose sum equals to k. This suggests that we can use the prefix sums technique to calculate the subarray sums and the hash table to keep track of the number of occurrences. Therefore, we can build a hash table with a key equal to prefix sum and the value equals to the number of occurrences. In addition, to detect whether any subarray sums equal to k exists, and how many times it exists, we can use the prefix sum I equals to prefix sum I minus k plus k. This property suggests that instead of directly computing the subarray sum equal to k, which is computationally very costly, when we know that we have prefix sum I, and if the key prefix sum I minus k already exists in the hash map, it means the counterpart subarray sum equals to k must exist, and the hash table prefix sum I minus k will tell us the number of occurrences. To further clarify this point, I break down the nums array into three parts. You may pause the video to study this in a little detail. As you can see here, the first two parts sum up to be the prefix sum up to the ith index, and it can also be broken into two parts, prefix sum I minus k, and the second part with a sum equal to k. Now, directly searching for subarray part 2 with sum equal to k is computationally expensive. Instead, if we know prefix sum I and prefix sum I minus k exist, then the counterpart with sum equal to k must also exist. With all the background knowledge introduced, we are now ready to write the code. So first of all, we declare a hash map using dictionary, and then a count initialized to be 0, and then we iterate through the nums array, and then we also have a prefix sum initialized to be 0, and for each number in the nums array, we add to the prefix sum. Okay, and if this prefix sum is in the hash map, we add the hash map, the count to be plus equal 1. Oh yeah, and the hash map has the key is the prefix sum, and the value is the number of occurrence. And if it's not seeing the hash map yet, then we initialize this prefix sum as the first time it's seen. And then finally we return the count. Okay, but where is the k part comes in here? So there are two conditions we can detect the subarray whose sum equals to k. The first is when the prefix sum itself equals to k, and the second condition is when the prefix sum minus k is seen in the hash map. And you're equal to the hash map equal to the prefix sum minus k. So this is condition 1, and this is condition 2. And then that will be all the condition for us to find the subarray sum equals to k. And we submit this for evaluation. And let's see, it's judging, and it's accepted. Faster than 96% of all the submissions so far, 200 milliseconds, pretty good. There's actually a way to further improve this code. So because when the prefix sum equals to k, and it means the prefix sum minus k is 0, we can have the 0 here as the key, and the value will be plus 1, so the value will be 1 here, and then we can simplify the code this way. Okay, again we submit this for evaluation. It's the same, and accept it again. 208 milliseconds, very good. Now we analyze for complexity. So this has a time complexity On, since we iterate through the nonce array only just once. And then it has a space complexity, also On, since we use the hash map to store the key value pair. Okay, so that's all. Thank you very much for watching.